2 to 3 years projects they'll be going to take such things. Okay. Next is incremental development model. It is going to be, now you see that the description here also same thing. It is outline descriptions about that particular project. Specification is there. Is a concurrent activities simultaneously that they will be going to do it. Specification, development, validation, they will be going to do simultaneously here. Once the specification comes, development is going to be done, then validation is going to get interested there and there, then and there itself. Then after that validations, it goes to the initial versions of that. It is getting released. Then any problems are going to be there in that. Those things are again comes back to the specification and development, validation. This process continues here. Then some intermediate versions are going to be there. Okay. Because some versions are going to be, first initial version will be going to be get releases, then intermediate versions are going to be get releases. Intermediate versions, it is going to get tested and any suggestions are going to be there in that. Those things are going to be considered for the development. Finally, final stage, the final working of the model is going to be delivered. So basically what happens basically in this is, here agile methodology as well as plan driven, both are going to work in this. Agile methodology, why it works, because once the initial version is being released, any problems are going to exist in that will be taken care by the development team. Again they will develop and again that will be released. Then intermediate stage, once it is released, that again and again the repetitions of those things are going to be, we will be going to call it as a beta versions of those things. Okay. Any requirements from the customer side, if it comes, okay, this is not going to work, that is not going to work, small errors are going to come, it is hanging, system something, some flaws in that they're going to find. Those things are going to be get again connected with the developer, and he has to rectify those things, and finally the development team will give the final version of the system, and that will be identified and it should be released to the customer side. Okay. So here also we have the plan driven as well as agile methodology concepts here. The same thing that it is. The benefit is only one thing, is that immediately you will be going to get the feedback of that process and will be going to rectify it. Not like a waterfall model. At the end only you will be going to get the results in that. One problem in this is process is not going to be visible. Okay, number of times that it is working. Okay, so we'll be not going to see that which process is going on in this, which model is working over there, and we'll be unable to see that. And one more thing is that the structure tends to degrade a new increments in the whether it is being added. Already once we have been added, so improvement of that, immediately they want the improvement of this. They given the specification, according to that it has been written, but again the new increments are going to appear for that. So it is a tedious work that it is going to be. So because of that, some points it may corrupt the system also. Okay, so this is two drawbacks of incremental development model. So here we are going to use one thing, that is COTS, that is commercial off the shelf systems. Nothing but already ready-made products are going to be there. Those things that we will be going to take and we will be going to integrate it. So first way of development that they can able to do it. See, one thing that we can observe in this, Word 2000, okay, Word 2000 has been already developed. You can see the ribbons over there in the top 2 or 3 layers will be there. Those things are already similarities. If you consider for the Excel, PowerPoint and all these things for the Microsoft Office, all it is going to be same working functionality is there. First only they will be going to take a lot of time for the first product, second product and third product, just plug and play like that. COTS, they are all available. It is going to be commercial off the shelf products are going to be available. They'll use those things and they'll be going to develop it. Faster way of development, that is. And already those products have been tested and it is being executed. So no need of testing again that particular product. So that is the advantage that they'll be going to have it. That's what the reused elements can be configured only for the integration purpose that it is going to be. Okay, then reuse and standard approach for building the main types of business systems. Any system that you will be going to use this type of applications. Okay, where and all this reusable softwares are going to be available now. Standalone systems that you can able to make it. Then by using this .NET and G2E frameworks, you can able to integrate the components. Then we have web services. There also you can use the standards for remote invocations and all these things that you can able to execute. Means somewhere that product is going to be from a different location only, through using the web nature, that you can able to activate that particular product. So here, reuse oriented software engineering, how it is getting reused. You see that for again requirement specification, whole system. I mean to say that from first chapter to the last chapter, you'll be going to see all these things, that is specification, development, evolution, reuse and maintenance. Okay. First is a requirement specification is there, then software discovery, new things. Okay, then evolution. One second.
Hello.
Okay. Software discovery, any problems are going to be there, those things are going to be discovered. Evolution, new things are going to be implemented. So requirements refinement means already requirements are going to be there, specifications are going to be there. Refined one, that it is going to be taken to the next stage because of the reuse of the product, that will be going to make it in that. Application system availabilities here, components also going to be available. You will be going to use those things to adapt for the new system. Configure the application system. Here components are going to be added. Adapt the components which are going to be available for that particular functionality. Then develop the new components. Possibilities are there. Already if it is existing, use it. Otherwise you will have to develop that system and components and you add it. Finally integrate the system. So you are reusing as well as new developments also, you will be going to do it for the application. Same thing, that is requirement specification, discovery and evolution, requirement refinement, application system configuration, component adoption and integration. That's what I said in this particular diagram. Okay. Advantages and disadvantages of this system is reduced cost and risk are less. Software is developed from scratch. If a new system that you want to develop, that time cost is going to be reduced because of already ready-made product as the components are going to be available. Risks are also going to be less. So fast way that you can able to design. Delivery also fast way that you can able to develop and design and deliver it. Then requirements is going to be if you going to compromise for some things. Okay, inevitable system may not meet some requirements. Okay, that time you have to compromise for some of the things. Loss of control over evolution and reuse system and elements. Sometimes what happens, you can lose the control of the new things. Okay, you cannot able to do more than some required features that you cannot able to add in that. Okay, that time there are some disadvantages of the this particular system. It is. Next is model is spiral model. It is. You see first the spiral model first, like this it is. Okay, so it is also going to have 4 stages. First is objective